Welcome. For those who don't know me, I'm Eve McDonald, EMESRT Coordinator. Today's webinar is focused on the EMESRT Industry Initiative Mobile Equipment Fire Management. Our webinar presenters this afternoon are Tony Egan, EMESRT Advisory Group member representing Glencore, and Tony's currently in his vehicle. He's kindly stopped to make this presentation, so thank you for that, Tony. And also Mark Gearson, who's the EMESRT Advisory Group member and the project lead for this particular project, representing Rio Tinto. Tony's going to be covering agenda item 1, and Mark will cover agenda item 2, 3, 4, and 5. So thank you, everybody. And Tony, over to you.
So welcome, everyone. My role today is to introduce you to EMESRT. If you're not familiar with EMESRT, some of the people on the call may well be, but we'd like to give you some background because I think it helps provide a deeper understanding of what Mark's going to go through. So I think, you know, what's EMESRT about was a group that was formed in 2006 by mining users. Our original influence was to try and look at the designs that were coming out of the factories from the OEMs and point out the problems that we were having and see if we could get those resolved at a factory level. Our job originally was sort of focused at the OEMs, thinking, well, that's where the gear comes from. But I'll talk later on about how that focus changed over time. So how do we do what we do? Well, it's about presenting a common industry voice and really that staying very focused on the health and safety aspects of operating and maintaining mining equipment. You know, up front, I'll say that, you know, over the years, a lot of people have come to EMESRT and wanted us to do this or do that or be involved in this or be involved in that. And we've had a discipline to say, no, we're going to stay very focused on the particular issues that we're here for. And by doing that, you know, we do an inch wide and a mile deep approach on things, where there's other bodies within the industry who've tried to be a mile wide and an inch deep on things. And, you know, there's a great saying about if you try to be everything to everybody, you'll be nothing to nobody. And, you know, we've been quite structured in the way that we've done what we've done, and I think it's proved successful. So, you know, the whole outcome of what we're doing, and today's a good example of that, is delivering practical outcomes for the industry, not only the users, but OEMs, researchers, third parties, all coming together in a way that can bring a better understanding of the problems that we face and hopefully then lead to some better outcomes all around. Diversity of thinking and understanding and challenge and everything else has been another key thing that's brought about EMESRT's successes over the years in improving situations in relation to the health and safety on equipment. So one of the things that we identified back in 2005-06 was that there was a design gap. The things that the OEMs were manufacturing and delivering to us didn't actually cover all of the problems that we faced in the workplace. So the interesting thing about the design gap is that the only people who can shrink it are the OEMs, because they're in control of that fundamental product that leaves the factory. There's lots of third-party people who've worked and built businesses in filling that gap over the years. And to be realistic, you know, there's always going to be some level of gap. But where there's some really significant issues that require integration, you know, we're really trying to drive a change in the designs to accommodate those things. In terms of the other things that we had to do was typically, as engineers, we would see a problem because we were dealing with them either through a third-party solution or whatever, and then we would actually go and talk to the local engineers from the OEM dealers or whatever, and that would all flow back to the factory. And the engineers probably agreed with what we were saying was an issue, but when they got back to the factory, the people that actually control the R&D funds were actually the marketing group, not the engineering team. And the key change there was that we had to focus on working at that marketing level. And so the first visits we did in 2006 to all the OEMs in the United States originally was we met with the senior management and the marketing people, because that was really the ones we wanted to influence change, because they're the ones that control the dollars. And one of the things that EMESRT has done by coming together as a common voice and defining problems, not solutions, is that's been well received by the OEMs. You know, we're not trying to tell them how to fix it, but we tell them what our issues are. And by doing it with a common voice, the marketing people go, geez, all these people are saying they got the same issue. if we can come up with a good way to fix that, we've probably got a pretty good market. And so what we've delivered is a business case that drives investment in change and change in the products. And over the years, that's really evolved and has become a more rapid pace of change. When we first came together, there was 6 or 7 companies. We all sat down at the table and had our vision and mission statements for our own organisations. And pretty quickly, we came together and formed a statement around what our vision was, and that's up on there. And the purpose was an interesting one, but it's really talking about, because we can only influence, we can't tell anybody what to do. It was, our purpose was to accelerate the development and adoption. And I mentioned earlier about our original focus was on the OEMs, which was development. But pretty quickly we came to realise that adoption is a big issue too, because if these things get built and we don't actually buy them or don't utilise them, then they're not going to continue to be built. So working with users and educating users about the problems or the risks that they face in the workplace has been a big part of what EMESRT has done, and particularly in the last couple of years. And the topic that Mark's going to talk today about is actually quite a significant chunk of it is around user problems and how they need to be recognised and addressed. So over the years, we've had some key principles. I mentioned a few things about how we've operated, but designing beyond standards was one of the first ones. So when we first met with the OEMs in 2006, they all said, well, the first thing we do is go and get all of the minimal standards and say that's the minimum we've got to do to put a machine out in the workplace. But the challenge is that you've got to design beyond standards if you really want to solve these problems. We all know that standards take years and years to develop, and they lag. And with the pace of change and the issues that we have, waiting for standards isn't going to get us there. Now, it's not to say we shouldn't follow up and lock these changes into standards later on, but it's a hard road. Another key principle is balancing engineering and behaviour. The engineers, I'm an engineer myself, so we were trained in engineering, but we weren't really trained about how humans work and how humans interface with the things that we build or maintain. And that human factors piece has been a massive chunk of what EMESRT has done over the last 15 years, is really looking at how the humans interact with these things and how do we get it right and how do we get it wrong. So that's been a big shift. Recognising the value of task-based design reviews, and that flows on from this human factors focus that says if you're really having a task-based approach, you're really integrating how the human works in that process. And we've introduced that not only at a user level, but back with the OEMs through the OMAT process and the ED processes. And it's really changed some of the thinking at that fundamental design level. The other thing that is important, that appreciating that OEMs do it best with end users involved. I mean, they're good designers, but they're not good users generally. And we're good users, but we're not great designers. So the answer is, if we're really going to solve these problems as an industry, we've got to come together, and EMESRT works to create that mechanism for us to come together in a common platform. And again, that's what Mark's going to talk to do today in terms of the fire topic. The last piece is a really key one that, traditionally we had problems with our equipment. We used to talk at the OEMs or the dealers and whatever and tell them, you've got to fix this or you've got to do this or whatever. Well, really, that was somewhat disrespectful in the fact that they've got a business to run. They've got challenges the same way we do. And so open two-way engagement is really about listening to both parties, understanding the constraints and the opportunities of both. And by doing that, actually find a better way to work together and move forward. And that certainly, I think, has put us in good stead over the years. And, there's a level of respect and trust that's been built up with the OEMs and through the EMESRT process. And it continues today. Another key area of importance is what we will or we won't do. And I mean, in this space, the way that we operate, trust from both the users and the OEMs is a really important thing. If you lose that trust, we're dead in the water. So, what things that EMESRT will do is focus on the design of earth-moving equipment and surface and underground mines. Again, I was talking about the scope issues I talked before. We're not trying to be everything to everybody. We'll provide aligned design expectations based on risk. I'll talk later about the design philosophies. That's the mechanism for delivering that. We'll involve interested mining companies in the industry and share openly with all interested OEMs and third parties. So although to be a member of EMESRT, you've got to be a mining user. It doesn't mean that we try to think we can solve everything ourselves. And Mark will talk later, but this is a great example of how we've brought the mining industry community together to help us understand this topic and bring forward some depth of understanding of the problems. And then the last piece is share leading practice to assist mining equipment users achieve their health and safety goals. And today's another example of one of those sharing practices and the way we operate. What we won't do is discuss commercial issues or anything of an antitrust nature. I talked before about how important trust is. We won't provide approval for OEM or third-party designs. Very early in EMESRT, people said to us, well, are you going to certify this stuff, whatever? Well, the reality is that logistically and physically it's not possible, but equally, the moment you certify something, you put a floor under it, and it's a bit like standards. That becomes the minimum thing, and people just work to that. EMESRT's approach is about engendering a leapfrogging of things. We don't talk about best practice, we talk about leading practice, because at a point in time you lead, but at some point in time someone else will come up with something better, and there'll be a change in that leadership of thinking. So it's really important that we don't share confidential information in the way that we operate. And the other thing is we can't impose adoption of the solutions on any member company. The approach we've taken, and it's a tough one, it would appear, is that education and understanding is what we're trying to bring to the industry and users and designers. And through that education and understanding, people will make different decisions about what they do, either designing or using the equipment. And that's all we can do. And it's a tough road, but in the long term, it's the most sustainable and probably the most influential. There's 5 factors that we sort of summarised. We were asked a few years ago by a few people, what's made EMESRT successful? So there's all these underlying principles and the mechanisms we operate. And we were challenged to think about this, and we came up with these 5 things, which was that, working with an industry level focus, the people come into the room with their company hats on, but pretty quickly they take their company hat off and they get their industry hat on, and they really focus on the issues at hand and work genuinely together. And I think that's we had a workshop in Brisbane a couple of weeks ago with 70 people from around the world in the vehicle interaction space. And those 3 days were, hats off and everyone really focusing and driving forward on the issues. Having a real world business understanding of the financial drivers and leverage, and that's both sides. That's both on the user side, but also the OEM and the third parties. What drives their businesses? What drives their investment? What drives the things that make their business tick and makes them do things and not do things? And that's something I think is really powerful, because a lot of the material that we produce is actually tailored and set up to actually suit the OEMs and their people and the way they function, rather than handing them the stuff that we do as users and how we see it. And the uptake of it has improved because of that. Understanding that innovation is market driven, not pushed by technology. There's lots of evidence out there about, the person that turns up with a widget and says, you need this bit of technology, it's going to work for you. But as a user, if you don't really understand your problem and therefore know how to utilize that technology, you're not going to succeed. And the overwhelming evidence is that where the users come together and define the requirements and then pull the technology or pull the improvements forward, the success rate is very high. Good governance. Obviously, we're running an industry organisation. We need to have the right structures and funding and risk management, renewals and continuity in the process and people. And we do that with a light touch. We run on a very, very small budget of administration. Who doesn't want to hear that, but we do. and our focus is spending money on solving the problems, not running an organisation. And that's a big difference to some of the other industry bodies that you see out there when you look at the percentages of what they spend on running their organisation versus solving issues. We stand quite apart from that. And the last piece is senior management decision-making endorsement, both again on the OEM side and also on the user sides. And it's a really important piece that we vertically up and down the organisations get that input and buy-in so that we are aligned to, are we focused on the right issues? How do we focus on those issues? Well, every year we have a get-together about August. We do a structured review of where we're going with the topics that are currently on foot, what are those emerging topics, and we discuss the resourcing and the funding and all the other things that might be needed for those topics, and whether we actually stretch too far, and if we take on any more topics or anything, would it actually diminish the benefit of what we're doing in the other topics? And we're quite hard on ourselves about that. And at the moment, I think we've got three major topics running, which is vehicle interaction, the fire topic, and the tyre topic. There's a couple of others bubbling away in the background, the diversity, which is really not gender diversity, but diversity of people, anthropometric size, etc. And live work is another area that's sort of popping up, and people are asking us to take a look at as well. So we meet, the advisory group does that every year. We set a budget, and the budget actually sets the membership fee. We don't just charge a fee for the hell of it. The actual membership fee is actually set around the basis of the work plan for the next year. And it's not about amassing money in the bank. It's actually just having enough resources to fund the activities that we need to fund to get these topics moving forward. And again, membership, we don't need a huge membership. What we need is committed committed people that are involved and bring their knowledge and experience and their diversity to the table of thinking. Just amassing members is not a goal for EMESRT. The membership that we have provides a core direction and an amount of funding that gets us moving. But to the involvement of lots of other people is really where the benefit comes. And Mark will talk a bit about that in this topic. I mentioned earlier about defining problems that we have and risk, and the way that we do that is through documents called design philosophies. Why are they called that? Well, often when you say to someone, I've got a risk assessment or this, or but it's different to what you've traditionally done, you give it to someone and they look at it with the same lens and glasses that they looked at the previous version in, and they really don't get an understanding. When we started down this path, we came up with a name that everyone sort of had to stop and go, what's a design philosophy? Which is great because we actually get to give them the definition of what it's about. And what is it? It's fundamentally a collection of the major problems under a series of headings that we face as users that if addressed will create a safer and healthier workplace for our people. And so it started out as 15 many years ago and was amassed back into 8 key ones in 2009. And today's topic, DP4 there, fire, is the one we're talking about. But equally, we've got tyre and rims under DP2. The vehicle interaction stuff is under DP5, machine operation controls. And those design philosophies were a succinct document, generally 2 pages, front and back, and they utilised photographs to give a demonstration of some of the problems. They had defined objectives and problem statements for potential unwanted events. But over the years, one of the things we've found, and it started in the vehicle interaction space, is that sometimes the problems are more complex and need greater understanding than the design philosophy format provides. So what we've done is develop documents called performance requirements that sit under and complement the design philosophies. And we've now got DP5 in the machine operation controls for vehicle interaction. Mark's going to talk to you about PR4 for the fire topic, and I dare say we're going to end up with one for tyres at this point, and we're going to next year probably take a look at some of the other topics, whether we need some of that breakdown. But for instance, DP1, access and egress and working at heights, today is still the same as it was in what we developed in 2006, and today it's still impacting and having design changes made against it. So it's delivering the result in the format that it's in, so it probably doesn't need to change. But interestingly, live work sort of deals with exposure to harmful energies. It also might deal with health impacting factors, manual tasks, and even the confined space and restricted work area DPs. So I think that's going to be an interesting topic to discuss. So yeah, they're a core of things. We use them in a number of ways. When we do an OMAT, these are used to prompt the people involved in the OMAT and the task-based risk assessments about how are they analysing the tasks and what should they be looking for in terms of those tasks on those particular bits of equipment, and they become a prompt. They're also used in the ED process as well, which really defines the residual risk after the design's complete. or residual exposures on a particular design from an OEM. And I think they're an opportunity to be used by users who are running day-to-day risk assessments in their mine sites and things like that. It's a lot of leading thinking around what the problems are that we face. And I hear a lot of people go, oh, we're different. We're a different commodity. We're this and we're different that and everything. But the more work we've been doing over the last few years, and Mark's going to talk about the control framework structure that we've evolved, the more we're alike than we ever realised. And I think that's also bringing us together as an industry community, and I think will accelerate the ability of the designers to start to address these problems better, because we're all saying that, yeah, that's the issue and that's how it needs to be addressed. So thank you. I'm going to hand over to Mark, and he's going to really talk about why did we get involved in the fire topic. Thanks, mate.
Look, thanks very much, Tony. Thanks everyone for joining us today. Good morning, good afternoon, depending on where you're coming to us from. I guess Tony's given a really good overview of the EMESRT process, and today I'm going to talk a little bit about the mobile equipment fire project and the work that we've been doing to understand what goes on there and what it means for those of us who operate mobile equipment, surface and underground, for those who are on the call. So in my presentation today, I'm going to talk through 5 key things. First one, the background and the EMESRT approach, including who was involved. Second, the control framework, which really allows us to see this issue through a different lens. And I'm really excited about this. This fire subject, it's often been done to death. And the work that we've done through the control framework, which we've been developing over the last couple of years, and from our other EMESRT projects, really allows us to see this fire problem in a way in which we haven't typically seen it before. So stay tuned for that. 3, the importance of current state assessments, as approximately 80% of the mobile equipment fire events we do have, we've actually played a role in them as operators and maintainers. So that's worth having a bit of a think about as well when we get to that point in the presentation. 4, the status of the work, which has involved many individuals from many organisations, and some of which are on this call this afternoon. And 5th, the next steps, including what tools and reference material is available in our knowledge hub and available to the industry to be used now. So you remember Tony talking earlier about, working industry issues and then making information available freely for people. Well, we've got some resources that might be able to help you depending on what your problem is, and you'll be able to focus in on that with the control framework, I guess, discrimination. So we're currently leading 4 active industry projects at the moment. There's the vehicle interactions, there's mobile equipment fires, there's tyres and rims, and as Tony said, there's a couple of others that are just sort of in their early stages. There's a human factors one that we've been talking a little bit about as well. So what typically happens, each one of those projects is led by an EMESRT advisory group member representative, who then provides the strategic oversight and coordinates the technical working group or subgroups, as the case may be. And this presentation today is really around the mobile equipment fire management project. So what sort of kicked all this off? Well, as it happens, we had a very significant fire in one of our underground operations in 2018, where we lost a tool carrier. And that incident involved an emergency evacuation of over 500 staff and really tested our emergency procedures, and everyone right down to rescue chambers and self-rescuers. And because of the robustness of our emergency response and our ongoing, safety refreshers and, disaster management trials and recoveries, nobody was hurt. However, it did bring all sorts of attention, and for the wrong reasons. And those who are on the call will know what I'm talking about. So in our instance, the asset was totally destroyed with less than 1,500 operating hours. And normal operations did not recommence until we were really comfortable, we understood what we had to do going forward. So in our instance, we had equipment design issues, we had fire suppression installation issues, fire system integration issues, which triggered a discussion with the EMESRT advisory group to understand if others across the industry were experiencing similar events. And as a result, we initiated a project with the focus to understand what was happening across the industry and regions, and to see if there was an appetite to participate in an industry level program or a mobile equipment fire working group, as it turned out. That work identified that fire-related incidents were still compelling and recognised that the mining industry really needed a step change to improve its performance in current fire management. And obviously the project was kicked off as a result. So part of our industry work typically involves a document search or a document review, just the same as any other, research type project. And as Tony mentioned in the opening part of the presentation, we referenced our EMESRT design philosophies that were developed way back in 2005, 2006. And the particular one we pulled out was DP4. And the objective of DP4 is to prevent harm related to equipment fires to as low as reasonably practical, including consideration in design for foreseeable human error. So just think about that. You heard about my comment earlier about 80% of the incidents we do have often been at our own hand. Just have a think about that. So DP4 contains what the intended design outcome should be, i.e., the elimination of sources of ignition and fuel, and, the protection of the operator should fire occur, and so on. And our project, as an extension of the original work done on DP4, emerged. So when EMESRT typically kicks off a project, we typically develop an array diagram, and you can see there in the horizontal and vertical bars that surround the array diagram, with the sun on the right-hand top corner, which is meant to simulate what we're working towards, which is consistent good practice, maintenance and ops, innovation to improve our current practices, and equipment design innovation. So the array diagram typically provides the EMESRT community with a visual of what is already out in the industry, identifies who's doing what, where the gaps might be, which then helps inform how EMESRT approaches the industry engagement strategy, the stakeholder analysis, and allows us to bring all those moving parts together to help understand where we need to influence, where we need to engage, or where we need to work, where work is outside our remit. Obviously we can't, and we never intended this to influence standards. for example, or sorry, take on the accountability of writing standards, but we can certainly influence them. And you'll see that there's a number of references there to Australian standards and ISO standards that, you know, we have supported that has formed part of this project. So there's a colour codes, typically mean blue is a parcel of work that needs to be actioned. Orange is typically a parcel of work that's underway, and green is a parcel of work that we've completed. And we typically span those descriptors across the sectors in the array diagram to actually show the role that EMESRT is playing, and where specifically we are facilitating, you know, engagement between, you know, either factory designers and end users, or academics, or research organisations, or whatever it might be. And as a result of this, to support the process, I think it's probably also worth mentioning is that Tony, Matthew Clements from Anglo American, and myself have also been provided ISO liaison status in the last 12 to 18 months. What that means is that there's a conduit for us to be able to provide direct end user input into relevant standards that are emerging or under review, that are aligned with our particular project strategies and parcels of work we've got underway. So, you know, there's a recognition from ISO and Australian standards that EMESRT has a really good process and a good pipeline to experienced, capable people to help them, you know, move the dial where they need to around standards. But as Tony said, standards are lagging. So these are the organisations, academics, individuals, fire system designers, fire system maintainers, academics, consultants who have supported EMESRT, and all the major miners and key contacts and organisations that have contributed to our project. So our technical working group consists of a broad range of industry stakeholders. So you can see there's over 58 members now representing 30 organisations. And our sole mandate was to identify design inadequacies and industry leading practice, review the current research and identify any gaps, consult across the industry and share knowledge, and develop and promote documentation to support self-assessment and obviously risk reduction. So if we use the universally understood heat, fuel and oxygen fire triangle, the group discussed and documented the fire event areas of influence using the control framework, which I talked about earlier, which I'm really excited to talk about today. So what is the control framework? The control framework, for those who are on the call and have a bit of an engineering eye, will recognise it as, if you like, a reverse failure mode effect analysis. So the control framework approach is aligned with failure modes and effects analysis, human factors, and the definition elements of the International Council of Mining and Metals critical control methodology. And I'm sure many on the call will recognise or be familiar with them. It allows realistic inputs and experience to be mapped to the safe and productive operating states required to deliver business purposes. The mapping step uses required operating states, credible failure modes and business inputs, interlinked components to develop a deep understanding of the complicating problem. So if we look at this example here, it uses a whole of system overview and a structure that's linked to detailed operational practices. And if we work this way, it provides information and insights about the dynamic interconnects between people, equipment, and the work environment, and work groups carrying out different tasks and the overall coordination of that work. And this promotes like a systemic identification of improvement opportunities. So if we have a look at this in just a little bit of context, we say, well, what are our required operating states? Okay, so we've got half a dozen of them, and I'll show you shortly what that looks like in the context of our unfortunate fire event that I spoke about earlier. What are the credible failure modes, or how do we lose control? And then very specifically, how do we specify, how do we implement, how do we monitor, and how do we control? And when we start laying it down this way, particularly the specify, implement, monitor, and control, they, if you like, become the actions or business inputs. You heard me talk about business inputs that we all take to help maintain or sustain the health of a particular asset and prevent it from catching a light. And if we have a look at this from a critical risk management perspective, what we find is that a lot of the controls that we currently hang our hat on as and think that everything's running fine actually don't have any monitor and control steps in place. So what that means is we've got a procedure, but how do we know whether it's being followed? How do we know whether it's practical? How do we monitor if there's an erosion of that control? I'll give you an example: speed limits or fitness for work. They're all really good examples of controls that we have that can fall into disrepair, and we don't find out about it until there's an incident because we haven't been adequately monitoring and validating. As I was saying, this is where some of the insights sort of help develop. So the mapping process, causes us to take a bit of a systemic review and allows for an assessment of the robustness and reliability of the business inputs. And it follows, like I said, these steps: confirm the safe and productive outcomes are relevant at the enterprise level. And these are typically the required operating states, and they're the basis of how the control framework is set up. Identify and catalogue the credible failing modes that can compromise each of the required operating states. And then based on those credible failure modes, identify the business inputs or the particular actions that prevent or mitigate the required operating states being compromised. Prepare a mobile equipment fire control baseline and cite standards, guidelines, procedures. So you reference all of that material and it helps you understand where the gaps are. And I guess it's probably also a really good time to talk to the enabling culture that's necessary on our sites, because for this process to actually deliver, we've got to have, open and transparent and competent leadership, coaching, and review, and a reporting culture as well, so that we actually really understand what is practically happening in the field. I'll give you an example. We might write a procedure and it says we need to do this, this, and this. And when we go and test it with the end users, the people who we've requested that action of, they tell us, oh no, we don't do that. You can't do that because of this, and this. All right. So that allows us to actually really understand what is actually happening compared to what we think might be happening or what our original intent was. And that's really quite powerful. So this is an example of the actual control framework outcomes from the very specific incident that we had happen in our business. So we had 6 required operating states, 6 credible failure modes, and 7 business input groups that also allowed us to do a whole heap of, industry experience cross-checking and regulator documents, and we just found just a continual churn and repeatability of the same stuff happening in a different location on the same type of assets or with the same mechanism of fire event. So, you heard me talk earlier about a systemic review and assessment of the robustness and reliability of the various business inputs. So this really, and that's why I talk about, it isn't just a desktop exercise. You've actually got to really go out there and be prepared for some very confronting feedback against all of the specific checks and measures and things that you think are in place or are listed in your fire prevention files or your asset prevention files, because you'll get some ample feed for improvement. I guess the control framework current state assessment, which is what I've just been sort of talking through probably a little bit prematurely, is a critical component in that process. And it's really important knowing where you fit in relation to leading practice. So, as I just mentioned, we develop work as documented, and we update that against work as done. And we do that through interviews, operational observations, and a structured site validation workshop where we actually bring about the correct environment such that, it's non-punitive and it's open and people, the right people in the room to actually allow the conversation, or out in the field as the case may be, to get the best result. And then we update the site-specific mobile equipment fire baseline, including preparing the user requirements for potential technology providers, because what we're attempting to also understand is, how can we potentially use technology to support us make more informed decisions, or to support us in a more proactive way. And I'll give some examples of those in a minute. So as we took this approach, you heard Tony talk about, DP4 needing to be extended and provide a little bit more detail. And this is really where performance requirement 4 came in, which we'll now talk to. So I guess performance requirement 4 was developed by the EMESRT technical working group, comprising, all of the individuals that I'd already introduced, but most notably from all areas: end users, original equipment providers, fire system designers, fire system maintainers, research academics, just a whole range of really competent, capable, experienced people. So in the third quarter of last year, we had several one-on-one webinars where we also discussed our findings with OEMs, and we asked for the opportunity for the OEMs to give us feedback into PR4 before we published it. And we did that because our OEMs are partners to our success on our sites. And we didn't see this as a mandate. This is something where we try to promote a two-way conversation in the same theme that Tony has already talked through regarding the facilitation between the end users, because we're pretty good operators, or we like to think we are, and our factory designers who are pretty good factory designers, right? So that really helped identify a whole range of well, that actually fed PR4, and that was tabled last year, and it was published on the 22nd of December, which is a very significant day for both Tony and I, right? So we're both born on the 22nd of December. So the performance requirement 4 should really be read in concert with design philosophy 4, so that people sort of understand, the linkages between the potential unwanted events and the credible failure modes, and then the functional or performance requirements of any solutions. So this is one of the outputs of the control framework. And I was really excited when I saw this come together, because you can straight away see through the color coding that there's a parcel of work that sort of sits with mobile equipment design. There's a parcel of work that sort of sits with fire system detection and suppression design. There's a parcel of work that sits with mobile equipment maintenance management. And there's a parcel of work that talks to how our operating companies have emergency and crisis management processes, and how all that stuff sort of comes together to help us manage both the micro issue, but also the wider end-to-end macro issue. So it's important to highlight that performance requirement 4 does not consider the emergency management and crisis management, because that is something sort of outside our mandate and is typically very much site specific in terms of its application. So finalising PR4 in consultation with the industry stakeholders was a really important milestone. And what this helped us sort of demonstrate was that we all really need to work together if we're going to get the result that we want, which is equipment not lighting, not coming to light, not catching light. There we go. We've got one of those tongue tires there. This is a summary of the work we've completed to date. We've reviewed the EMESRT design philosophy 4, and we're in the process of updating it with, we've actually updated all the words. We're just trying to get the animations that we want, such that we remove some of the dated photos, and that stuff will then stand the test of time going forward. The regulator information from multiple jurisdictions, incident reports, bulletins, position papers, the operating site company and industry documentation, research and technical information, including the incident taxonomies, relevant standards and guidelines, and most notably, I want to highlight two parcels of work. I'll talk to one now and one a little bit later. As we were kicking this work off, there was a new standard that came out, 19296, which really talked to mining mobile machinery management underground, and we've also validated the control framework at 2 multi-day industry workshops since we kicked the project off. we've published the performance requirement 4, and that's available on our website. And as I said, Design Philosophy 4 has also been updated. Our Knowledge Hub has been developed, including a navigation graphic, and it's got some curated content uploaded. And there's still more to do, but as incidents occur, what we're doing is reviewing that against our control framework, which is actually just it allows us a digital horizontal and vertical snapshot, so you can actually dig down an inch wide, mile deep, either from the side or from the top, depending on what you're trying to understand, right? So it's really, really useful from that perspective. And we update it, and that then allows us to keep it relevant from an industry knowledge perspective. And I think that's been one of our wider industry challenges in the past as well. You know, once you put something on a website, how do you keep it relevant and up to date? So our body of knowledge is an attempt to do that. So this provides a little bit of an overview of our Knowledge Hub. It's linked to the topic areas and subtopic areas identified in PR4, which I've talked to, and users can easily navigate to their topic of interest. And you know, as the Knowledge Hub becomes more mature, though I must say, this is probably the most comprehensive collection of wider fire industry aggregate data that I've seen in any location. So I wouldn't say it was immature by any state of imagination. I think that you could confidently use it today. And the Knowledge Hub's available via our EMESRT website. There's a bit of a plug there for, that's pretty easy to understand if anyone wants to go and have a bit of a look. So that's just talking to the subgroups that are under each one of those. Note that even though there is a little bit of content under the emergency response and crisis management, our project did not include those elements from a sphere of influence perspective. So I guess our next parcel of work is to engage, and we've already commenced the process, and that's really around, you know, taking the detail that's been flushed out in PR4 and speaking to our OEMs in some detail about that. So, you know, talking about the vulnerability of existing fluid supply mechanisms, you know, like, you know, rubber oil supply lines or braided oil supply lines to turbos, and you know, how challenging it is to actually keep that lubrication system rigorous under all conditions, given all the work and maintenance and events that go around the turbo, as an example. And there's lots of others, you know, where we might have to stand on hydraulic hoses that then to perform maintenance that then stress the coupling. You know, there's a whole range of those sorts of things, you know, and there's the use of flammable materials in existing energy drive and associated construction systems. And, you know, you can see photos there. And in our example, I can tell you that some of the cowlings and some of the engine covers, once they reach a certain flash point, actually become fuel. So, you know, that's another example. Designs that allow flammable material buildup. What does that mean? Well, depending on, you know, what commodity we're working in, or where the particular where material is introduced. You know, rags in an engine bay is a good example. Coal build up in horizontal surfaces adjacent to hot exhausts, or in and around or conductive material that can congregate in and around key connections from a battery's or a machine's voltage or electrical control system. Then we've got the fire system, the integration of that fire suppression system, logic, and that's right through isolation. So if we're an operator, how do we know whether the fire system's been isolated or not, and whether we should be operating the machine? How does the machine send a signal to the fire system to tell it when it's safe to operate? And if you think about the context of machines that need to safely come to a stop before the fire system activates, these are just some of the examples. And modern machines today often have CAN bus type control systems, which means that their control system is regarded as software, or as it's got an IP, and it's proprietary. So how do we break into that? Because we can't break into it anymore and get the signals we need to do the third party fire system or activation piece, like we used to when things were relay and wire controlled. Right? So they're just examples, right? And that goes right through to how do we anticipate that we're going to have a fire event? How do we know that something's leaking or something is overheating? How do we know when the fire system should go off, and how it should go off, and what messages or signals as an operator, because we're bombarded with alarms and warnings. How do we discriminate and work out which ones of those are more important than others, such that we actually take action, and it's not just another red light or a yellow light that I've just pressed the alarm acknowledge button on, or I've got a stick jammed in it so that I don't hear it buzz, right? Those sorts of things. Inability of fire suppressants to extinguish certain flammable materials, and I think this is starting to become more relevant as we see the emergence of alternative powered assets. We can't just continue to use what was our fluoride-free foam fire systems on some of those chemical type fires. And then that leads me a little bit to the emerging energy drive system technology, and I mention that because as these new platforms are designed, how do we help our factories, our OEMs, make sure that as those designs come on board, they design out a lot of the issues with the human errors that we introduce through existing designs, if that makes any sense. So there's a bit to do there. So the next steps, we're going to continue engagement with the industry through our monthly meetings into 2023. We're going to get the illustrator detail into our design philosophy forward and get that published. Obviously, the continual update of the control framework, as I talked to, and the knowledge hub, and then finalising some of the mobile equipment fire management control effectiveness baseline work that we've had going with a couple of the member companies. Publish our fire management project report, which I think is like probably a week or two away. I've seen the final iteration today. Continue discussions regarding the reinstatement of 13649. You heard me talk earlier about the several ISO standards. This one has been picked up by one of our working group member company representatives, and they have got the avenue to be able to reinvigorate this standard, which is really good, because those who don't know, this project was cancelled in 2019 by ISO due to resourcing constraints, and our project has been able to sort of bring it back, and it's now on the agenda, and it will take its own torturous road until it becomes published, which will probably be 3 years down the road. But it talks to fire prevention in mobile equipment, and that's at the core of what this working group was established to create. We've just also this month commenced afternoon working group sessions, similar to what we've had in place in the vehicle interaction space for many years. And we've done that because we now have a wider advisory group membership, both tier 1 and tier 2, and we're covering a greater area of a global footprint, such that we want people to be able to attend and contribute in reasonable working hours. So that's why we're doing that. And we're now also looking at battery electric vehicles in the context, with the possibility of further industry work, because there's a bit of a linkage there to the elimination of live work that Tony talked to in his initial introduction, and some of the outcomes of this work as well. So in today's presentation, I've talked through the 5 key things, why we've focused on fire and who was involved. We've talked about the control framework, which really allows us to see this issue through a different lens. So I'm really chuffed about that. 3, the importance of current state assessments, as around 80% of the fire events we do have are at our own hand. And 4, what was achieved, including the launch of the Performance Requirement 4 and the Fire Knowledge Hub, which have resources available in the industry now for the audience, and the next steps, including what tools and reference materials are available and can be accessed now. So in closing, I just want to thank all of the technical working group members and other industry participants and their sponsoring and member companies for making this project a reality, and to the EMESRT advisory group for their support in bringing the initiative to life. And I'd also like to thank everyone for their attention.